Hello there. Thanks for sharing a little quiet with me tonight. In this calm, I'd like to set a small question on the bedside table and let it glow. Does time exist without a universe to hold it? We use time all day, without thinking appointments, recipes, sunsets, songs, ending right on cue. But underneath those habits is something stranger. Is time a basic feature of reality, present even when nothing moves? Or is it something that appears only when changes can be compared, when matter settles, memories form, and a story finds its order? We'll wander gently between the outer world and the inner one, from gravity's pull and expanding space to the clocks you carry within, rhythms that keep you steady, memory that links moments, awareness that turns difference into a flow. No rush, just a slow, friendly look at how a word so ordinary might be hiding a deeper kind of wonder. If this kind of nighttime science helps you unwind, a quiet like and a soft subscribe help others find it too, only if it feels right. For now, we'll let the question rest within reach and begin our unhurried journey into time. Does time exist without the universe? The words sound simple, almost casual, like something you might ask while washing a cup late at night. You've said time your whole life. You've checked clocks, counted hours, kept birthdays on a calendar, waited for a song to end, for a message to arrive. Under all those minutes and plans, there's a quieter question, one that asks not what time does, but what it is, and whether it could be there if nothing else were. It helps to notice time the way you notice a voice finishing one sentence and beginning another. There was the instant you pressed play, there's the one unfolding now, and there's the one about to arrive. Each moment feels separate and yet naturally ordered, a gentle line that seems to lean forward. You might not even feel it unless something interrupts the flow, a long hush on the phone, a light that fails to switch on, a song that skips. Then the current shows itself again, or its absence does. But what exactly are you feeling? When you say a minute has passed, you're not holding anything in your hand. You're noticing change, sound shifting, thoughts turning, a room settling. Time appears braided with motion and transformation. If nothing changed, would time still move? Think about the place around you, the way the air sits in the room. Somewhere, a distant appliance hums. Somewhere else, a shadow climbs an inch. You know this is the present, but you also know this present used to be the future. And in a blink, it will fall behind you. Everything leans one way. The feeling is so ordinary it almost disappears, and yet it frames your whole life. Imagine lifting that frame, just for a minute. No ticking, no motion, no before, no after. What would remain? It sounds abstract, but the question is only asking you to step a little away from clocks and calendars and the reminders that tug on pockets and wrists. Instead of measuring time, look at how it quietly shapes things beneath the measurements. People sometimes say, time is an illusion. You'll hear it in a lab hallway, in a philosophy class, even tucked into a novel. It doesn't mean your days are fake. It means the thing that feels most basic might not be the foundation. Maybe time is something the universe makes as it goes, not something it floats inside. A bit like music. Without notes changing, there is no song. One endless note isn't a melody. It's a ceiling of sound with nothing to count against. Physics sharpened this idea in surprising ways. When Einstein introduced general relativity, he asked us to stop thinking of space and time as separate rooms. They're one fabric space-time stitched together so tightly that you can't tug one thread without moving the other. Mass bends this fabric. Planets, stars, your body, Everything with weight tells space-time how to curve, and that curved space-time tells everything how to travel. Strange as it sounds, this means time does not pass the same for everyone. Down near something massive, time runs a little slow compared to higher, emptier places. This isn't just clever talk. It's measured, corrected, relied on. The GPS in your pocket works because satellites adjust for relativity every moment. Without those tiny corrections, your map would drift by kilometers each day. A small difference in time would bloom into a large error on the ground. If time depends on the structure of space-time, then the deeper question grows louder. Without a universe, without the fabric itself, what would time be resting on? Go back as far as you can imagine, past galaxies and dust, past stars forming, past light itself. The Big Bang is not an explosion that erupted into an empty stage. It's the appearance of the stage. In the usual description, space and time come into being there. Before the Big Bang isn't just unknown. It may be a kind of direction that doesn't apply, the way north of the North Pole doesn't point anywhere. The wording sounds normal, but the concept folds in your hand. None of this demands a quick answer. It only asks that you notice how steady ground starts to feel like soft sand when you stare at it long enough. We lean on motion to feel time's flow, the sweep of a second hand, the moon's slow path, the steady pulse in a wrist. Then the question returns. If nothing changed, no particle moved, no field fluctuated, no state transformed, would time still be there? This isn't just a late-night puzzle. In some of the equations that reach deepest into the structure of things, especially where quantum mechanics meets gravity, time doesn't always show up the way you expect. The mathematics can relate states to one another without drawing a bright arrow from then to now. The connections matter more than a universal metronome. And yet you are not a set of symbols. You are here, and something feels like it is unfolding. That tension invites a gentler thought. Maybe time is not fundamental in the way length or charge seems to be. Maybe it emerges when the right conditions are present, when matter interacts, when information spreads, when entropy rises and arrangements tend to loosen. The arrow you feel might be tied to the way ordered things become more mixed, the way a tidy shelf relaxes into clutter unless you keep tidying. In that view, time is the shape change takes when there are enough pieces to keep track of. Without change, without a story to arrange, the word might fall silent. Not everyone sees it that way. Some thinkers flip the picture and treat time as the deeper thing, with space arising from it. On that account, a kind of fundamental ticking, nothing like a clock on a wall, but just as steady, carries on even when nothing else happens. The world could be empty, but the drumbeat would remain. So far, there is no experiment that can settle this in a single afternoon. We live inside the question, and our tools reach for it from within. So the thought returns, steady as a lighthouse. If there were no stars, no particles, no fields, no geometry, could time still be there? One side says no without change. Without relationships between events, the concept loses its meaning. Time is the label we give to order, to comparisons, to the way one thing follows another. Take away the things, and there's nothing left to label. The other side says yes, time could be the condition that allows any universe to appear at all. Not a thing that begins, but a quiet openness that always is. Both pictures can be held lightly, and while the mind leans toward the grand and the distant, something closer deserves a seat beside them. You. A person is partly made of memory, stitched together by the order of remembered moments. You wake, you pour coffee, you speak a name, you feel a small joy or a small weight, and each of those has a place on an inner line you carry. That line is how you know who you are, and just as importantly, when you are. Maybe the sense of a flowing time is the work of that inner librarian, organizing, labeling, setting one page after another so the story can be read. If the past is what your brain records and arranges, then time, as you feel it, could be something minds build as they move through change. None of this requires choosing sides. The idea is to drift among these shapes of thought with the same patience you'd have for an evening walk. A step, a pause, a look around. The science is not leaving you behind. It's walking at your pace. Relativity makes room for clocks that disagree and for satellites that must be corrected so your phone can find your street. Cosmology reminds you that before may not always make sense. Thermodynamics whispers that order relaxes, and that this easing might be why the world feels like it moves forward. And the quiet theater inside your skull suggests that memory and awareness might be the loom on which the feeling of time is woven. Perhaps the question doesn't need a verdict so much as a gentler gaze. Maybe time is the universe's way of keeping events from crowding one another. Maybe it's the mind's way of stitching change into a life. Maybe it's both layers of faint music under a scene you didn't know had a soundtrack. We don't have to force an answer. It's enough to notice that time might be fundamental, or it might rise from relationships and fade when they do, and to feel how a word we've used 1,000 times still opens into rooms we haven't finished exploring. And if those rooms extend outward, they also turn inward. Before asking whether time could exist without a universe, it helps to notice how completely it lives inside us. We treat it as familiar because we use it all day long. We check the hour, wait for a moment to pass, make time for someone, run out of time for something else. Those are habits wrapped around a feeling, the sense that something keeps moving forward, steady and unseen, with no button to pause or rewind. The puzzle is simple to say and hard to hold. What is that forwardness? Is it truly out there in the world, or a pattern your mind casts over change? People like to picture time as a river carrying moments downstream. It sounds right until the image starts to wobble. If time is flowing, what is the river made of? If it moves, what nudges it along? Try a plainer approach. Say that time is what keeps everything from happening all at once. Neat until you look closely at what happening really means. For anything to happen, something has to change. A tone begins. A lamp clicks on. A heel finds the floor. Change is the signal that a slice of reality didn't match the one before it. From those signals, the mind arranges before and after. Without them, the world is only a still photo. No story, no direction, no time. That's where it turns strange and interesting. You can't scoop up time with a spoon. You only see its footprints. Wax sliding down a candle, a child outgrowing a shirt, a tree leaning after years of wind. These are not time. They are changes you read through the lens of time. You don't point at time itself. You point at something that changed and say, yes, time has passed here. So maybe time is a bookkeeping system for change. But then what about places where nothing changes? Imagine a sealed room, no sound, no drift of air, no tiny motor humming, no dust settling. You step inside, and later you step out. You would still say time passed for you. Yet inside the room, if absolutely nothing shifted, does the word time have any work to do? Or does time become real only where there's something to notice? Some physicists are comfortable with that second path. Deep in a few of our most successful theories, time doesn't show up the way you expect. In parts of quantum mechanics, the math can describe possible states and how likely they are without spelling out a step-by-step march from one state to the next. It's as if before and after are not baked into the equations. They appear when the rest of the picture is in place and you look at it with a creature's eyes. Another place the ground shifts is general relativity, where time is knitted to space into one fabric, space-time. A heavy thing sitting in that fabric Earth, a star. A black hole bends both the distances we move through and the rates at which clocks would tick. The result is wonderfully plain and wonderfully odd. Time does not pass at a universal rate. It runs a little slower, close to large masses, and a little faster where gravity is weaker. A watch on a mountaintop really does tick a touch faster than one at sea level. You won't feel it in your bones, but the difference is there, measurable, dependable. Time, then, is not a single drum everyone hears in unison. It's local, personal, tied to where you are and how you move. If time can stretch and sag, and if it can even slip out of certain equations, maybe it isn't part of the deepest layer of reality. Consider temperature. It's real, you know, the comfort of a warm mug and the sting of winter. But no one talks about the temperature of a single atom. The idea makes sense only when many particles dance together. Temperature is a summary of their collective motion. Time could be similar, not a thing at the base of everything, but a property that appears when enough pieces interact and change in rich ways. That line of thought opens to time as emergent, something that arises from patterns rather than dictating them. Picture a wave rolling across the ocean. You can point to it, surf it, measure its height, but the wave isn't a separate object. It's the choreography of countless water molecules moving in sync. Time might be that kind of pattern, visible and useful, yet built from relationships underneath. Entropy gives that pattern a direction. In thermodynamics, entropy tracks how many ways a system can be arranged. Start with low entropy, say, blocks stacked neatly, and let the system evolve. It tends to move toward higher entropy. The stack tumbles, pieces scatter, order loosens. That tilt is the arrow you feel as forward. The laws of physics, in their simple forms, don't mind running backward. A movie of two billiard balls colliding could be played in reverse and still obey those laws. But your daily world doesn't behave that way. A cup shatters on the floor and the shards never leap back into your hand. Heat spreads and refuses to gather itself without a push. From a low entropy beginning, the universe has been sliding toward more possible arrangements ever since. You don't sense that cosmic trend directly, but it frames the background of every ordinary moment, giving time the flavor of one-way travel. If the universe had begun high in entropy, would the arrow feel different? Would there be an arrow at all? Maybe time, as you experience it, is the label for the path from tidy to mixed, from arranged to scattered. When people say time is an illusion, they often mean the one-way flow belongs more to memory than to mathematics. You remember the past, you don't remember the future. That fact alone builds a sense of direction. A brain that stores yesterday and cannot store tomorrow will feel a current, even if the deepest equations are ambivalent about it. The feeling is stubborn. You can't opt out of it. Thoughts have a rhythm. Senses have delays. Awareness blinks from instant to instant. You live with internal clocks that tick in different ways. One sweeps over about 24 hours, the circadian rhythm that sets sleep and wake, hunger and alertness. Others are short and nimble, the ones that let you tap a beat, guess a second, wait for your turn to speak without stepping on someone's words. They aren't perfect metronomes. They drift with age. They bend under emotion. They stretch in boredom and shrink when you're absorbed. Minutes thin out when you're busy and thicken when you're stuck. In sleep, that sense may fade to a thread. Even language nudges how you picture the flow. Some people talk about the past as something in front, visible, known, and the future as behind, hidden, approaching from out of sight. Others swap the directions. Some imagine themselves moving along a line of time. Others picture events moving past a stationary self. There isn't a single agreed map, and that variety hints at a deeper point. Time might not be an object, but a model, a tool your mind uses to navigate change. A map is real in its usefulness, without being the territory. Your sense of time could be that kind of map. Still, not everyone thinks time is secondary. Some theories keep it as fundamental, even when nothing else is present. In those pictures, time is like a metronome, waiting in the quiet, a dimension that continues whether anything plays along. But then another puzzle rises. If absolutely nothing changes, no fields flicker, no particles exist, no processes unfold, what would mark one instant off from the next? If there's no difference between now and later, can those words mean anything? It's like trying to imagine color without light. The word is familiar. The experience requires a world to live in. That comparison points toward a gentle compromise. Maybe time does not stand alone. Maybe it belongs to systems the way motion does, the way shape does, the way temperature does, emerging when there's interaction, when differences can be noticed, when something can actually occur. A melody cannot exist as a single, unchanging note, no matter how long you hold it. The song appears when notes relate. Time, too, might appear when states relate. The question doesn't vanish. It just softens at the edges. If time is only as real as the universe is busy, did it begin with that busyness? And could it ever fall quiet? Those wonders tug outward toward cosmology and inward toward biology and mind. Both directions belong in the picture because the story of time seems to need a stage and a storyteller, the fabric that sets possibilities, and the creature who reads patterns in that fabric. To see what the word time is allowed to mean, it helps to keep both in view, the way clocks disagree on mountaintops and shorelines, and the way a person stitches moments into a life and calls that stitching a flow. So let the thought rest here. Time may be fundamental, quietly present even when nothing stirs, or emergent, arriving with change, information, and memory. Either way can be held lightly while you listen to the room, to the hush between words, and to a mind that finds order by laying moments side by side. And if we're holding the inward thread, follow it gently into the quiet machinery you carry, how time lives in you, measures you, steadies you, often without asking. As you listen, your body is keeping time with hormones that rise and fall, neurons firing in patterns, electrical pulses gliding through delicate circuits, and soft rhythms that began long before your first opened eyes. You don't have a single clock. You have a choir. They don't tick like a wristwatch. They oscillate, drift and correct, pause and restart, and somehow keep you walking in step with a world that won't wait. The most familiar of these rhythms is the circadian one, a near daily cycle built into almost every living thing. It is why nights tend to coax you towards sleep, and mornings lift a little brightness into your chest, even when you haven't checked a window. It's not perfect, just steady enough that the body uses it as a schedule board for thousands of small tasks. When to ease melatonin into the bloodstream, when to nudge core temperature upward, when to open the gates of appetite, when to tilt the brain toward dreams. This rhythm isn't only background noise. It brushes almost everything you feel and do: how quickly a scrape closes, how sharply you recall a name, how resilient you are to a passing cold. Pull it too far off alignment and threads begin to loosen. People who work under shifting nightlights or cross oceans often know the sensation: fog behind the eyes, heavy limbs, appetite wandering, a mood that won't sit still. The body doesn't merely exist in time. It relies on a sense of time to keep its balance. Near the crossing of your optic nerves sits a tiny cluster of cells, the suprachiasmatic nucleus, your master timekeeper. It listens to light. Not the storybook glare of noon or the picture of a sunset, but the simple fact of brightness reaching your eyes. With that signal, the master clock keeps the rest of your rhythms tethered to Earth's day and night. Take away that anchor long enough, and the whole system drifts. Not wildly, just a little each day, like a boat untied from the dock, sliding along a slow current. Even without sunlight, though, your body still keeps time in its own manner. Inside your cells, proteins rise and fall in repeating loops. Certain genes switch on and off in waves. Feedback circles reinforce these patterns across tissues and organs until billions of small clocks hum together. Each part contributes to your sense of order, like towns in a wide country, all setting their bells from the same faint note. Beyond the daily rhythm, you carry quicker timers. These aren't tied to the sun, but to attention and action. When you tap your foot to a song, hold a pause just right in conversation, catch a ball, or guess when the microwave will chime, you're leaning on short interval timing networks. Neurons don't count seconds the way a device does. They create ripples of activity, nested pulses that give your movements a beat and your thoughts a cadence. These pulses don't measure time in the abstract. They generate patterns that make coordination possible. They are the reason you can press a word into the exact space between two other words, or feel when a silence is generous and when it's too long. Those small clocks are flexible to the point of being slippery. Emotion tunes them, context stretches them. Fear can make seconds bloom into long corridors. Boredom can make minutes sag with weight. Delight can fold hours into something that feels like a handful of minutes. In danger, the brain seems to add more frames to the film, giving you finer detail per instant, not because the outer world slows, but because attention sharpens its lens. That is part of why time is so hard to pin. In one corner, it behaves like a physical dimension, bending near heavy masses, agreeing with satellites. In another, it behaves like a mood, warped by memory, focus, and feeling. Memory might be the quiet keystone. Without memory, time doesn't merely feel odd, it loses footing. Imagine a room with no movement and no sound. If your memory slipped away every few seconds, the room wouldn't feel timeless. It would scarcely feel like anything at all. Time needs comparison, the present set beside a trace of what just happened. In certain illnesses, after trauma, or under particular drugs, the brain's ability to hold sequences and judge duration shifts. For some people, time can feel jagged, stalled, too quick, or stretched thin. The universe doesn't change its laws in those moments. The interpreter changes, and with it the shape of experience. Sleep weaves into this story in a way that is both simple and strange. It isn't only a nightly pause. It resets how you process time. In dreams, the clock in your head can melt and reform. A handful of waking seconds can host an hour-long dream narrative. Loops appear, order slips, events jump their rails. Yet underneath the fluid surface, the body keeps its deeper beat. Breathing softens into patterns. Muscle tone quiets. Hormone levels trace their arcs. Repair crews go to work on schedule. Even when the narrative of time loosens in a dream, the body's clocks keep humming. That layering surface flow, memory beneath it, rhythms beneath, that is why you can wake from a dream that bent time into knots and still be ready for breakfast at roughly the same hour. When your internal clocks fall out of step with one another, or with the world outside, you feel the mismatch in the plainest ways. Jet lag is the famous example. The sun says morning while your hormones argue for night. Sleeplessness pushes signals out of phase, and suddenly focus, appetite, and mood are playing different songs. It isn't just discomfort, it's disorientation, because somewhere inside you, identity leans on continuity, the thread that runs through waking and sleeping, thought and sensation, yesterday's plan and today's first step. That thread depends on timing, that more or less agrees from one part of you to another. All of this folds back toward the larger puzzle. If the universe didn't exist to offer sunrise and sunset, or the pull of gravity, would time exist in any useful sense? For a person, time is not only out there, it is a structure built from memory, rhythm, and expectation. Take those away, and time doesn't simply become hard to describe, it loses meaning. And yet, another picture presses in. Imagine a single person adrift in featureless darkness. No stars or sounds, only awareness. The heartbeat would still thrum, hunger would wave up and fade. Thoughts would rise and sink. There would be no precise way to count, but there would be a felt, unfolding this, then this. The sense of sequence can survive even when landmarks vanish. Then press the thought further. Strip away senses, strip away memory, strip away even the awareness that thoughts are happening. Leave only bare existence with no contrast, no mark to notice. What would time mean there? The words begin to blur. Without contrast, without the capacity to set one instant against another, time becomes unreachable. Maybe it isn't gone, but there is no one and nothing to call it by name. That nudge brings us to a relational view. Time is the description of how things compare, how one event lines up after another. Without events, there's nothing to order. Without order, no timeline. Without a timeline, no past or future, just sameness with no edge. The same idea peeks out when you look at a clock closely enough to see its secret. A clock is a device that isolates a motion, a swing, a vibration, a turning, then counts it with patience. Take away the movement, and there is nothing to count. The clock may sit unbroken, but it has nothing to do. In physics, this insight stretches far. Some approaches to quantum theory describe the world by listing possible configurations and how they hang together, not by parading moments past a universal stopwatch. The sense of this, then that, looks like something minds add when they read the relationships. Stillness becomes stranger in this light. A moment with no movement might not be a moment at all. If nothing changes, there is no sequence to track, no contrast to register, just a state that is whole and uninformative. You can't say it lasted a second or a millennium. Those words demand a reference that isn't there. Timelessness, then, isn't a mystical curtain so much as the name we give to total sameness. If a state doesn't evolve, no internal or external clock could declare its length, because length would be a story without events. The edge of a black hole offers a dramatic stage for this feeling. As you approach the event horizon, time for you feels ordinary. But to a faraway watcher, your processes appear to slow, stretched thin by gravity's pull. From that distant view, your clock crawls. It hints that time is not a single universal river, but something woven with where you are and how space bends around you. Now, take away the mass, take away the curve, take away even the watcher. Imagine a place with no particles or fields, no forces to push or pull, no ripples to chase. Saying that time passes, there might be like saying a ruler measures in a world with no lengths, or that a shadow falls in a world with no light. The sentence is grammatically fine, but functionally empty. A laboratory gives a gentler hint. Cool matter toward absolute zero and motion slows. Push closer to that unreachable floor and processes drag. At true absolute zero, motion would vanish, but we never quite arrive. What we learn along the way is telling. As motion dwindles, the system stops offering events to count. Time, measured by those motions, stretches until how long starts to lose its teeth. It suggests that time and happening are bound so tightly that when one thins, the other becomes faint as well. And yet, as you're hearing this, thoughts parade anyway. Even imagining perfect stillness, you are doing it in order, one image, then another. The mind is built from motion. Cells exchange signals. Neurons fire in shifting patterns. Blood travels its loops. Nothing about you is truly still, which is perhaps why true timelessness slips out of reach. It might exist, but our kind of awareness cannot stand in it. The way a fish cannot stand in dry air for long and still be itself. That doesn't make the idea empty. It makes it humbler. If timelessness is a real possibility, it may only be accessible as a boundary concept, something we approach in thought the way we approach the idea of a perfect circle, exact in mathematics, approximated in the world. Meanwhile, our daily lives are built from layers of timing, circadian sweeps, heartbeat pulses, steps in a hallway, speech rhythms, the quiet metering of memory. When those layers agree, the world feels aligned. When they slip, you feel the seam. There's another thread to pull, one that doesn't ask you to choose between time out there and time in here, but to notice how the two lean on each other. The brain is a prediction machine. It is constantly guessing what will happen a heartbeat from now, what word might arrive, where the fingertip will land, whether a face is about to smile. Those guesses need timing. If prediction arrives too early or too late, the world feels wrong. Anxiety can be thought of, in part, as the body's clocks running hot expectations, firing faster than events. Depression can feel like the clocks are heavy, the future slow to form. Even pain carries time inside it. Anticipation stretches it, relief shortens it. Interoception, the felt sense of your inner organs, keeps a ledger of rhythm, the swell of a breath, the squeeze of a heartbeat, the subtle waves of the gut. From that ledger, the brain draws a timeline of the self. Music makes this visible. A melody is just notes arranged in time, yet it can lift or loosen you in ways words alone cannot. When you sway with it, your internal pulses line up with an external pattern. That alignment feels good because it reduces error. The brain's predictions meet the world's arrivals. Lullabies slow the nervous system by giving it a simple, gentle beat to lock onto. A waltz invites your body to mark 1, 2, 3 with small muscles you never think about. Even silence in music, The held breath between notes has timing. It teaches you to expect and then rewards the expectation when the next sound blooms. Conversation does the same, only softer. You judge when to speak and when to rest. You feel the other person's timing and adjust yours to fit. Shared rhythm becomes shared understanding, which is one reason late-night talks feel intimate. Two sets of clocks settling into a similar pace. Storytelling rides this wave. A curve in the tale, a pause before a reveal, the way a detail returns after a long path. These are timing choices. They don't just deliver facts. They move your inner clocks, and for a while, bring them into tune with another mind. Under stress, that tuning phrase, the startle system cuts in, pushing spikes of adrenaline. Time may seem to splinter, either racing or slowing to a crawl. After the surge, once safety returns, the system tries to knit back together. Sleep deepens, appetite steadies, memory sorts. The repair uses time as both ingredient and guide. Long, slow breaths, long, slow walks, long, slow conversations that let the mind stretch from tight focus back into a roomier pace. All these layers suggest a gentle answer to a thorny question. Perhaps time is both the world's way of organizing change and the mind's way of making change livable. The physics outside you sets constraints, gravity bending rates, motion shifting intervals, matter cooling towards stillness. The biology inside you builds rhythms within those constraints, clocks that sync to dawn, pulses that keep steps tidy, memories that turn sequences into meaning. Where the two meet, experience happens. A day passes in the sky, a day passes in the chest. They aren't the same clock, but they shake hands often enough that life feels coherent. If you tilt the picture this way, the large question softens without dissolving. Asking whether time exists without the universe becomes a cousin to asking whether music exists without notes, whether walking exists without steps. You can imagine the concept in the abstract, but the living version needs pieces to relate. Time might be a structure that becomes real when there are differences to measure, rhythms to align, events to compare, memories to hold. Remove those, and the word remains, but it floats, unattached. Information offers another gentle handle. The simple fact that one configuration differs from another gives change something to lean on. When information spreads, signals traveling from here to there, uncertainty settling enough to become a trace, we say a process has unfolded. Your brain calls that unfolding time. A river calls it erosion. A seed calls it growth. Cooling atoms call it rest. No grand conclusion is needed tonight, only the noticing that before and after are braided into the body you live in, and that the braid holds even when ideas stretch. A moment becomes yours only when you can set it beside another. A day gathers meaning only when it knows where to land in the story you keep. And once you feel that, the next thought arrives almost by itself. What if the universe began in stillness, no expansion, no flicker, no unfolding, only a condition so even that nothing could be told apart from anything else? If nothing changed, would that be timeless? Or was a quiet kind of time, folded inside that sameness, waiting for the first wrinkle to appear? Some cosmologies picture the start not as an explosion, but as a transition, a perfectly symmetric, changeless state, slipping into one with room for differences, so that space and time, as we know them, could take form. In a condition like that, direction means nothing, and before has no foothold, but the instant symmetry breaks the instant. A tiny fluctuation finds its voice, possibility opens, In that picture, time doesn't begin at zero like a stopwatch. It begins when change can happen, when this can become that. The first moment isn't a bang, so much as a hush, disturbed by the smallest imbalance, and from that whisper, the story starts to have pages. There's no way to rewind the film and watch that shift directly. What we can do is ask whether such a moment even makes sense, whether before can be spoken in a place where there is no time to hold the word. If motion animates time and absolute stillness smothers it, then whatever existed prior to the universe, if anything deserves that word, might not sit inside our grammar of before and after. It would be something else, a region where our ordinary ideas don't travel well. That makes another question rise. If time comes from change, where does the change come from? Not just in bodies and brains, but in the fabric of the universe. It's tempting to imagine reality as a gigantic clock, ticking, counting, pushing events forward. But a clock is a device built to mark intervals. It has gears or vibrations, something that repeats so we can compare. The universe wasn't made to tell us anything. It doesn't carry a second hand across the sky. So when we ask whether the universe ticks, we're really asking whether there's a fundamental rhythm beneath everything, a beat that all things keep, willingly or not. People have looked for something like that rhythm by asking how small a moment can be. Below a certain scale, our tools and concepts fall apart. The Planck time on the order of 10, -43 to 10, -44 seconds, is a boundary that says, under this slice, our current picture of space and time stops working. That doesn't mean reality hops in steps of that size. It means our descriptions start to blur there. Even so, the question remains, is time continuous, gliding like a smooth line, or is it grainy, jumping frame by frame? Some ways of thinking about quantum mechanics suggest that time might not be fundamental at all, that what we call change could be a shifting web of relationships between states, with no background clock ticking in the wings. Yet we keep finding regularities that give us anchors. Light crosses vacuum at a steady speed. Particles vibrate with reliable frequencies. Atoms emit energy in precise amounts. We turn those patterns into standards. 1 second, by our definition, is tied to roughly 9 billion cycles of a cesium atom's radiation. That trick works because the laws of physics allow it, not because the universe intended it. Our ticks are choices we make, guided by regular behavior we find in nature, not by a cosmic metronome that beats for all. Step back, and the picture is both firm and strange. The universe changes, galaxies gather, stars ignite and fade, unstable atoms fall apart. But a single global clock doesn't survive close inspection. In general relativity, time isn't one thread. It's a mesh of threads, each one shaped by motion and gravity. Two identical clocks can disagree if one sits deep in a gravitational valley and the other drifts high above. Both are right for where they are. Time is local, not a universal drum. If there isn't one clock for everything, there are still processes that act like clocks for pieces of the world. Space has been stretching since the beginning. That expansion has a rate we can estimate from how galaxies recede. Not a tick, but a trend. Radioactive decay gives another kind of reference. You can't say when a single atom will change, but gather many, and the statistics steady into a half-life. These aren't synchronized by a master timekeeper, yet together they let us measure and predict. That's as close to ticking as the cosmos offers. Deeper down, the word change becomes slippery. Many physical equations relate states without pointing to a now. They don't say which way time flows, they just connect configurations. In some approaches to quantum gravity, time is erased from the blackboard. The Wheeler-DeWitt equation, for example, sketches a universe as a static landscape of possibilities. No marching seconds, no unfolding, just an all-at-once description. How, then, do we square that with the felt passage of moments? One answer is that time for us emerges from relationships inside the whole. Imagine a closed system so complete that from the outside, nothing about it changes. Inside, subparts can still shift relative to one another. Those correlations are enough for an observer to build a sense of before and after. Page and Wouters framed this idea elegantly. Time isn't fundamental to the whole. It appears for observers who live as parts, tracking how one piece lines up with another. We are change, measuring change, and the measuring is what gives the flow its feel. That doesn't blunt your experience. You still wake, eat, speak, sleep. You still collect yesterdays and imagine tomorrow. It only means those experiences may not be driven by an external tick. They may be shaped by structure, by how fields and particles and information relate. The universe in this view doesn't tick, it makes ticking possible. Within it arise systems that oscillate, decay, breathe, and from those we build clocks, not only in laboratories, but in minds and cultures. Even so, the urge to listen for a beat beyond the beat persists. It's a human question, rooted not in the expectation of hearing a click in the dark, but in the wish to understand the rhythm we carry inside. Following that rhythm backward is like tracing a river toward its springs. At some point you reach rocks wet with something you can't catch in a jar. The beginning of expansion is like that, less a sound than a change of state. The phrase first, second sounds straightforward, like a starter pistol and a dash into being. But that instant holds layers. It isn't only the onset of matter and energy, it's the onset of meaning. Rules firm up, space and time take recognizable shape, temperatures tower beyond any earthly comparison. The name Big Bang misleads if it makes you picture an explosion hurling debris into a pre-existing room. There was no room, no outside, no center. Space itself expanded, everywhere at once, which means what we call before, that expansion, isn't a place you could have stood to watch it begin. Second, itself becomes a delicate word here. We define it now using atoms in calm conditions. In the earliest flash, nothing was calm. The structure that allows a second to be defined was only just forming. We can still map a rough sequence because the universe we inhabit holds clues. Cosmic background light carries the memory of a much later cooling. Particle physics tells us how forces might split as energy falls. Observations of expansion let us roll the film backward carefully, because the real phrase near the start. There's a boundary we respect, the Planck time, around 10⁻43 seconds after the start. Before that, our two great guides, quantum theory and general relativity, pull in different directions, and the math won't stand still. We don't know what time means at that scale, or if meaning applies. Just beyond that veil, within a sliver of a microsecond, a shape begins to appear. At first, everything is so dense and hot that particles can't sit still long enough to be themselves. It's a roiling field of energy, uniform in its fierceness, chaotic in detail. Expansion cools the brew, and as it cools, forces separate. Gravity stands apart. The strong nuclear influence peels away. Later, the electroweak force divides into electromagnetism and the weak interaction. Those splits aren't decorations. They are the rules for how matter can behave. As the ocean of energy relaxes a little more, quarks and gluons start to hold together on the order of 10, -6 seconds after the start. The ingredients of protons and neutrons become less fleeting. Around the mark we call 1 second, neutrinos slip free to wander, and nuclear reactions begin to sketch the earliest elements in faint strokes. Full atoms will have to wait a long time, hundreds of thousands of years, until electrons can settle into stable orbits, but the groundwork is being laid in this tight, early interval. You'll often hear about inflation, a burst of accelerated expansion, perhaps beginning near 10, -36 seconds and fading by about 10, -32 seconds. In this picture, space stretches faster than light can chase across it, not because anything outruns light within space, but because space itself widens. That quick stretch can explain why the universe looks so uniform at vast scales, why the background glow is nearly the same temperature in opposite directions. Regions that are now far apart were once close enough to even out their differences before being flung from each other by the growing fabric. All of this, the cooling, the splitting of forces, the birth of particles, unfolds without a cosmic stopwatch, tapping a universal beat. When we say 1 second after, we are translating conditions back into a language that makes sense to us now. The clocks we trust today, the cesium oscillations, the carefully counted pulses did not exist in those first instants. What existed were processes, relationships, flows of energy into structure. Time, in the sense that helps us compare states, is braided into that unfolding. It isn't draped over reality, it grows with it. Seen this way, the first second is less a start than a turning, from a condition that could not hold lasting patterns to one that could. The transformation isn't marked by ticks, but by thresholds. When energy dips below this level, these particles can form. When it dips below that, these forces can distinguish themselves. When densities fall enough, certain reactions proceed. The sequence is smooth, a cascade guided by cooling and interaction. Each step makes the next one possible. The rhythm feels steady not because something outside is counting, but because the rules inside are consistent. The thought of stillness at the start returns, but it doesn't need to be lonely. If the opening state was perfectly symmetric, know this, know that, only a seamless whole, then nothing had the leverage to change. The very first departure from that symmetry, however small, would create contrast. And with contrast, you can draw a line, before the imbalance and after it. That line is the beginning of time in this narrative, not as a substance appearing, but as a way to tell that a difference exists. All the while, the search for the universe's tick keeps circling back to the same answer. There is no single hand sweeping over everything. There are patterns that persist and patterns that decay, oscillations we can rely on and trends we can chart, and from those we build standards. The cesium second is a human choice rooted in atomic regularity. A radioactive half-life is a statistical promise, not a promise kept by each atom. Expansion is a rate, not a drumbeat. The early timeline we recite, Planck time, inflation, quark soup, neutrino decoupling, forms a story that holds together because later measurements point back to it, not because a timer was running in the sky. Another layer deepens the picture. If, as some approaches suggest, the universe as a whole can be described without time, then what we call time may arise when we stop trying to hold the whole thing at once and instead look from within. Subsystems entangle. Information flows from one part to another. An observer compares a clock subsystem with a system subsystem and sees change. That comparison writes an arrow on the page. The arrow is real for the observer, even if the full book contains every page without flipping. None of this cools the warmth of lived experience. Days still open and close. Meals find their hour. The body leans into sleep. What changes is how gently we hold the word time. It may be what appears the moment difference becomes possible, the name we give to ordering once. Symmetry loosens, and patterns can endure. And asking for a before the universe may be like asking for north of the North Pole, a question that shows us the edge of our map. If the universe began in stillness, the first event was the right amount of not still. From that seed came expansion, cooling, structure, and memory. From those, nature built clocks, and eventually, minds did too. The second we use today, anchored to an atom's patient vibration, becomes a bridge thrown backward into an age with no such atoms at all. A translation that lets us speak sensibly about a time when sense itself was taking shape, which leaves a softer, unavoidable wondering. If time begins with change, what nudged the first change? What set anything in motion at all? Why did a universe begin, and why at that moment, rather than some other? Those questions press against the limits of time talk, because asking, why then, assumes a hallway of time was already waiting. Most modern models whisper a different answer. Time arrives with the universe. Before doesn't point anywhere, the way south of the South Pole doesn't. So instead of asking what happened in a time that wasn't there, we ask what conditions could allow time to appear. Some ideas point toward a quantum origin, a transition out of a high-energy, timeless state, a kind of structured nothing that isn't empty at all. Others imagine a grander neighborhood, a multiverse where pockets like ours bud off with their own spaces and their own clocks, none of which share a master timeline. In both pictures, time looks local, not global. It is stitched inside each universe and may not stretch across all of reality at once. That circles back to the meaning of a first second. If time is part of what began, can we honestly call that first interval a moment? A moment needs a rhythm to belong to. The first second might be less like a beat in an ongoing song, and more like the song's first breath, the point at which breath appears. And yet, here we are living with clocks, calendars, and seasons. Something about those earliest conditions was precise enough, balanced enough, to seed a world where complexity could grow galaxies, atoms, languages, thoughts. We can't peer past the boundary directly, but we can read what the moment left behind. A faint microwave glow stretched across the sky, a snapshot from hundreds of thousands of years after the start, carrying the imprint of tiny ripples that later became everything familiar. The phrase, "before the beginning," slips easily into sentences, into myths and first-page stories. But as you bring it close, it slides from your hands. If the beginning is where time takes its first step, then before is a word without footing. Still, we reach for it. We live inside sequences, so our instincts want the cause that came earlier than all causes. Physics doesn't scold that impulse, it just asks us to adjust it. The standard picture places the origin of spacetime about 13.8 billion years ago, not as a point in space, but as the onset of expansion everywhere at once. There was no empty room to explode into, there was only the appearance of the room itself. When we ask what came before, we're really asking for something outside the structure of time, something not earlier, not later, simply other. On large scales, general relativity treats space-time as geometry, bending with mass and energy. On tiny scales, quantum effects become loud. Where these two regimes overlap near the origin, we expect a new theory to speak, a quantum gravity we only partly understand. Until then, we hold possibilities as softly as we can. Quantum cosmology sketches one path. In some versions, the universe begins not from literal nothing, but from a quantum state with no time in the human sense, order without sequence. Under the right conditions, a fluctuation lets space and time appear within that order. It isn't a before that counts down. It's a configuration that allows a now to bloom. Some descriptions even frame the start as tunneling a transition like a phase change, not an explosion. Another path widens the map. Eternal inflation imagines a field that keeps spawning bubble universes. Each bubble has its own internal time. The field as a whole might not have any single clock at all. From our perspective, anything prior to our bubble is not a place we can reach, like a room with no door to the next. The word before may point to something real in the broader picture, but not to any event in our timeline. Time across bubbles doesn't line up. There is no common metronome. Cyclic ideas tell a different story. The cosmos could expand, slow, contract, and rebound, so that what we call a beginning is a turning point in a loop. In such a tale, the past isn't endless in the usual way. It's folded. Even then, time near the bounce might not behave as we expect. It could smear, bend, or dissolve for a heartbeat. Loop quantum cosmology goes further, suggesting that space and time might come in tiny units. In some formulations, the Big Bang is replaced by a big bounce. The universe contracts to a small but finite size, then rebounds into expansion. Time could thread through that turning, but in a quantum way that doesn't match ordinary clocks. These proposals are careful structures, not decorations. They try to extend the reach of physics without leaving its ground. Each one, however, eventually stubs its toe on language. Our words carry everyday assumptions. Before asks for sequence. Near the origin, sequence may not exist. The problem isn't imagination. It's that the thing we hope to imagine might not be the sort of thing that can be set in order at all. Picture a condition with no change, no cause and effect, no memory, no motion, not emptiness, but a state with nothing to compare. If no comparison is possible, past and future aren't missing. They're undefined, and yet the world we know unfolded. Something shifted. Space began to stretch. Matter formed. Forces distinguished themselves. With that, time as an ordering we can notice took shape. Events could be ranked. Clocks could be built. Histories could be told. It helps to treat the before as a boundary rather than a place, a shoreline where familiar grammar runs out. Not because nothing exists across the water, but because the structures that define earlier and later haven't appeared yet. Standing at that shoreline, we can still read the waves. The cosmic background tells us the early universe was astonishingly uniform, with tiny ripples just enough roughness to let gravity sculpt galaxies. That balance is remarkable. Too smooth and nothing forms. Too rough and gravity collapses everything quickly. The tuning isn't a proof of purpose. It's a signal that the first conditions were both powerful and delicate. The mind keeps worrying the same thread. What started the start? If there was no time, what does start even mean? A kinder phrase is symmetry breaking. The earliest condition may have been perfectly even, a state in which no direction was favored. The first imbalance, no matter how small, provided a way to tell one configuration from another. From that first difference, sequence becomes possible, and with it the feeling of time. Not because a hidden clock was uncovered, but because now there are moments to compare. Some models write this in the language of a wave function for the whole universe. In those equations, time isn't present. The universe is described as a static object of possibilities. Time appears when parts of that object are used to measure other parts. When an internal clock correlates with an internal system, what we experience as flow is coordination among subsystems, not a global river. In that view, the beginning is not an instant when a universal clock starts. It's a turn in the relationships that make measuring possible. If time doesn't go all the way down, causality may not either, not in the everyday sense of one thing pushing the next along a line. Instead of a first cause, there may be a first permission, a structure that allows space, time, and matter to arise together. Asking for an earlier trigger would be like asking for the square root of a color. The request sounds grammatical, but the categories don't match. It's natural to resist this. Every part of life leans on cause and effect. We miss a bus because the light stayed red. A seed sprouts because rain fell. A story continues because a page turns. Inside the universe, that logic is sturdy. Outside, it may have nothing to hold. So, our questions adapt. Rather than demand a date stamped on a clock that doesn't exist yet, we ask about the rules that made clocks possible, the geometry, the symmetries, the fields, the way fluctuations were allowed to grow. That shift keeps curiosity alive without forcing it to carry a weight it can't lift. Those rules have fingerprints we can read. The background glow isn't just a pretty picture, it's a map of temperature, ripples that trace density, ripples that later became galaxies. The distribution of elements, how much hydrogen, how much helium, a trace of lithium matches what simple early reactions would produce if the cosmos expanded and cooled along a certain path. The way structures cluster across space fits models where tiny initial differences grew under gravity's pull. These signs don't tell us what lies beyond the shoreline, but they sketch the beach beautifully. Holding the idea of a place without before grows easier if time is treated as built, not given. Then the origin becomes a workshop assembling the pieces that let a clock exist at all. Before that workshop opens, asking for a timestamp is like asking a seed for the shade of a tree it hasn't grown yet. A timeless configuration space is one way to picture such a workshop. Think of it not as a warehouse stacked with universes, but as a map of allowed arrangements. Nothing on the map moves. It simply includes points that correspond to moving worlds. Once a notion of moving exists inside them. Our universe would be one such point with internal structure that, when read from within, unfolds into the history we live. The selection of that point wouldn't require a shove from outside, no hand turning a key, only that the structure permits that kind of unfolding. If that sounds far away, bring it back to something gentler. In daily life, time feels like a smooth road, yet even here it is woven from relationships. Your watch coordinates with radio signals. Your phone's GPS corrects for relativity. Your memory places breakfast before your afternoon walk. Without those relations, the sense of flow thins. The cosmos may be the same at heart. No master chronometer, only many relationships weaving a fabric we read as time. There's a quiet freedom in this picture. It doesn't shrink wonder, it gives it a home. Before the beginning might never be something we can chart. Not because curiosity fails, but because charting requires axes that weren't available yet. Instead, we learn to read edges, ripples frozen into ancient light, patterns in elements, the pace of expansion, the birth of structure, and from those edges infer the conditions that let time bloom. If origins live beyond sequence, what breaks the stillness? A fluctuation, a tunneling, a phase change, a bounce. Our vocabulary is full of careful guesses. Each suggests a different texture for the threshold, a different way symmetry gives way to story. None has the last word. The search continues in equations, in telescopes, in accelerators that smash particles together to glimpse the forces that ruled when the universe was young. In the meantime, the practical shape of time holds. Days open and close, seasons wheel and return. Children learn new words, elders tell old stories. The arrow, we feel grounded in entropy's tilt, in memory's ledger, in clocks that agree well enough to build cities, keeps pointing. We can live comfortably in that arrow, while also holding a softer picture of its root. Time may have arrived with the first difference, not as a substance poured into a vessel, but as the pattern that became possible when sameness could finally be told apart. And if that's so, then wondering why the universe began becomes less like asking, what was the spark, and more like asking, what conditions allow sparks at all? It centers quiet architecture rather than a trigger. It lets the question do what good questions do, lead us to the borders of what we can say. So the next observation, the next idea, has a place to land. Picture, then, the gentlest start. No countdown, no drum roll, only a symmetry holding everything so evenly that nothing could happen, until the tiniest allowed deviation slipped free, and with it, the ability for moments to line up and be counted. From that permission grew stars and oceans, hands and voices, and the very possibility of before and after. Time didn't wait for the universe. Time arrived with it, and has been learning to tell its story ever since, through ancient light, through the way space stretches, through the quiet agreement of the clocks we carry and the memories we keep. We speak as if time pours past us like water spent, saved, measured, wasted so naturally that it feels like the world's default motion. Yet the deep laws don't insist on a forward flow. They describe possibilities and relationships. They allow change without demanding a direction. That small shift opens a wide door, the feeling of motion, duration, and this way, not that way, might be the surface of something underneath. A structure without hands or numbers that nevertheless gives clocks something to count. Think about warmth. You know hot and cold the way you know day and night. But temperature isn't a single fundamental ingredient. It's how countless particles move together. One atom has no temperature. Gather many, let them jostle, and warmth appears as a property of the crowd, not added from outside, emergent from within. Time could share that pattern. Maybe it doesn't exist at the very bottom. Maybe it arrives when enough pieces interact in rich ways, the way rhythm arrives when several instruments play, even if no single drum is the beat itself. Follow that thread into a picture where space isn't smooth but woven. Some approaches to quantum gravity imagine space-time as a network, nodes and links, loops and ties. No background stage, just relations. In such pictures, nothing moves through time. Instead, the network updates, connections rearrange. Those updates don't happen inside time. They supply what we call time. The ordering of changes is the story, not a stopwatch behind it. From the inside of the network, that ordered sequence feels like flow. From the outside, there is only structure and the way it can differ from itself. A gentler image is a flipbook. From the outside, Someone can riffle the pages quickly or slowly. The rate is theirs to choose. From the inside of the drawings, the character still lifts a foot after setting it down. Sequence, not a hidden pendulum, is what grants direction. Time lives in the order of frames, not in a metronome above them. Another angle leans on entropy and the quiet pull of probability. When there are many more ways for a system to be messy than tidy, weighting tends to favor messier outcomes. That statistical tilt is the arrow we feel. The equations that govern the details don't mind reversing. A billiard collision looks sensible forward or backward. But because the universe began in an extraordinarily ordered condition, motions that increase disorder are simply more likely. Coffee spreads into milk. A shattered cup stays shattered. Heat drifts from hot to cool. In this view, time is not a substance, but a habit the universe falls into as possibilities multiply. The path of least resistance is the one we call forward. Stretch that idea, and time begins to look like a ledger of updates. Quantum theory lets systems exist as many possibilities at once, until interaction prunes the possibilities into a particular outcome. Each interaction rewrites the ledger. You could say the universe records change one update at a time. The record isn't kept by a clock. The record is the clock. A new configuration joins the chain, and the chain's order is time as we experience it. At this point, the question creeps back in. If time is built from change, what happens when nothing changes? Consider a perfectly static state with no internal contrast. Without differences to compare, how long stops being meaningful? Time may still be allowed in the math, in the same way a ruler is allowed in a room with no distance to measure. But, with nothing to compare, the measuring loses contact with experience. No difference, no duration, no sequence, no flow. What emerges, then, may not be a thing you can pour into a jar. It might be made of comparisons and relationships of structure turning possibility into outcome. The ticking you feel could be the sound of differences happening, not a beat supplied from outside. If change is the ingredient, then time is the recipe taking shape in the act of mixing. This reaches toward a deeper hunch. Perhaps time is rooted in the logic of the universe rather than its matter. Not a material at all, but a framework that becomes real the moment a distinction appears. When symmetry breaks and states diverge, the stage for before and after springs into being. Time would then arrive with the first separations, not as a resource consumed, but as a result produced. Once you see time as a result, the questions about origins soften. Instead of searching for a birth minute, you look for the first allowed difference, the structure that made change possible in the first place. What kind of reality can host such structure? Can it exist without anything else? If measurement needs contrasts, then clocks depend on more than ticking gears. They rely on distance, on motion, on the way things occupy and leave places, which nudges a natural follow-up. Can you measure time without space? At first glance, the two feel separable, where versus when. But every honest clock is an act of motion. A pendulum swings, an electron oscillates, a photon bounces, an atom decays. Even the brain's sense of seconds rides ripples in neural circuits' activity in space. Ask how long, and you immediately look for a change that crosses somewhere. A swing from here to there, a wave from crest to crest, a signal out and back. Change without extension is a sketch with no lines. Relativity seals that intuition. Space and time aren't two tools in different drawers. they are one tool, space-time, whose shape depends on motion and gravity. Move fast, and your time dilates compared to a resting friend. Climb a mountain, and your watch runs a hair quicker than the one left at sea level because gravity's pull is weaker. You can't tug the when thread without wrinkling the where thread. They are stitched together. Measurement requires separation. You need markers to compare, a start and a finish, a crest and the next. Without space, where would you put the marks? You might imagine a solitary point that vibrates within itself. But the idea of vibration already smuggles in a kind of space, if not physical distance, than the geometry of a state space, a layout of configurations that can be visited. Frequency is a count of returns. Returns only make sense against a structure that distinguishes one configuration from another. Even in the quantum world, where particles blur and positions smear, there is extension and field. Probabilities spread across regions. Events involve couplings, exchanges, and paths. Crush it all down to a true point with no relations. And what you have left refuses to evolve, because evolve is the word we use when a relation changes. Some attempts at quantum gravity model space itself as a web of connections. Nodes link to nodes. Links can rearrange. Time, in these pictures, is the way the web changes relative to itself. Those connections carry the flavor of spatial layout, not distances on a ruler, but a map of which touches which. Remove every connection, and you remove the canvas for change. Without adjacency, there is no motion. Without motion, there is no way to tell one state followed another. You can see the same lesson hiding in the equations of general relativity. Flatten the geometry completely. No curvature, no volume, no separations, and you aren't left with lively evolution. You're left with a parameter that can be labeled T, with nothing for it to act upon. Press play on a paused video, and nothing moves. You have time in name, not in practice. A symbol, not a sensation. This makes the question gentler and more precise. It's not whether time could, in some ultimate sense, exist without space. It's whether it can do any work, be measured, be lived, without spatial structure. Most roads point to no. Time, as something that can be known and used, needs contrasts and paths. Without those, it turns invisible. Not necessarily false, just without a way to appear. Consider light, our favorite courier. It moves at a finite speed. That statement means nothing without a span to cross. Speed ties distance to duration. Remove distance and the bond snaps. How long has nothing to cling to? Even at the smallest scales we can talk about, events are smeared across regions, not pinned to zeros. The unfolding we call time needs that spread to define a before and after. This doesn't shrink time's reality, it anchors it. Instead of a fluid coursing through a bare world, time becomes the shape that difference carves into experience. When there are sequences to compare heartbeats, footsteps, orbits, oscillations, you can build a clock from them. When there aren't, the idea of a clock has no legs. In the earliest universe, space and time may even have been indistinguishable, both growing out of a deeper set of rules, where relation is more primitive than either distance or duration. As the cosmos cooled and stretched, those rules might have split into the categories we now recognize. If that's so, trying to picture time without space is like trying to taste without flavor, an act defined by what's missing. There is a quiet comfort in this. It suggests that the smooth flow we feel is an achievement, not an assumption, a pattern that appears where structure allows it. It also suggests that our ordinary picture space in one hand, time in the other, is a phase, a helpful way of organizing the world at our scale. Zoom out to the deepest levels and both might be shadows of something more abstract, a weave where arrangement and change are two faces of the same thread. Hold the practical end of the thread as well. All clocks need motion. All motion needs a layout. All layouts imply relations that can change. When relations change, time is readable. When they cannot, time goes dim. That's not a failure of reality. It is reality showing its conditions kindly and plainly. Rinse the idea through daily life and it stays true. Counting a minute on a watch, measuring a mile with a car's odometer, waiting for bread to brown, each is time traced through space. Your pulse, your breaths, the slow cycle of sleep and waking time traced through the geography of a body. Even memory lays moments out on a kind of inner map, arranging what came before and after so the story holds together. Wherever the story can't be arranged, when contrast fades, when sequence frays, time thins to a whisper. And so the picture that returns is soft but strong. Time isn't poured over the universe like glaze. It is baked in when differences can take hold. It leans on patterns, on probabilities, on relations becoming outcomes. It shares its roots with space because comparison needs a place to stand. When there is a stage for movement, time can be staged. When there is no stage, there is nothing to rehearse. From there, the big ideas of physics feel less cold. Emergence says time can arise without being present at the base, the way temperature or pressure arise in crowds. Thermal time says the arrow points the way it does because the world began unusually ordered and has been relaxing ever since. Network pictures say relations create the very scaffolding where next makes sense. Relativity says space and time are one geometry you inhabit, bending with mass and motion. Each view trims away the need for a hidden metronome and replaces it with conditions under which flow can be felt. If a single sentence has to carry the weight, let it be this: time is what change looks like when there is enough structure for change to be compared. That's why clocks work. That's why memories line up. That's why an empty, perfectly featureless state would starve time of meaning. The ticking you hear in machines, in music, in the body isn't the universe telling seconds. It's the universe offering difference. And difference, arranged and remembered, is how a life finds its rhythm. When two parts of a closed world compare notes, something like time can appear between them. One part can be a clock, the other a system, and the order of their mutual changes becomes a timeline that belongs only to that relationship. Nothing outside needs to tick. The flow is local and conditional, arising from correlation the way a melody arises from notes heard together. If the correlations stop, the sense of flow thins. If the clock and the system drift out of sync, the story loses its order. A practical picture helps. Imagine a pair of quantum spins, tiny magnetic needles interacting gently. Call one the clock. As its state cycles through a set of orientations, the other spin responds. For an observer who can only access the relationship between them, the cycling plays the role of seconds. The hand isn't moving on a dial. Instead, the joint state is weaving through a pattern of entanglement, and the weave has an internal order. Change, read as a sequence, becomes time. This way of thinking sits close to what some call relational or emergent time. It says the universe doesn't come with a single master parameter. It comes with ways subsystems can line up, compare, and keep a kind of score. If you could step outside the whole show and see every possible configuration laid out together, nothing would happen. But because no one stands outside, because every observer lives as part of the pattern, the local comparisons are all that matter. The page turns where the comparison changes. Entanglement is the quiet engine here. When two parts of a system are entangled, information about one is braided into the other. Measure this, and you constrain that. Let them evolve under a shared rule, and their correlations can serve as a ruler. The page-wooter's idea uses exactly this. Take the universe as a whole to be timeless, but pick a piece of it to act as a clock. Conditional on the clock reading 12, the rest of the universe looks one way. Conditional on one, it looks another. The sequence of such conditionals is what we call a history. Decoherence joins the story. When you invite an environment in, quantum systems are tender. A brush with the outside spreads their possibilities across many degrees of freedom. Interference fades. Alternatives stop mixing. What remains looks classical enough for us to point and say, this happened, not that. The environment isn't a nuisance. It's the stage crew that pins a loose, shimmering superposition into a set of stolid props you can actually walk around. With that pinning, records are created, traces and photons, vibrations, heat. Records let you compare. Comparison is the spine of time. At the smallest scales, the idea of a neat path vanishes. A particle doesn't draw a pencil line through space. It contributes to every permitted route with different weights. We recover a single, ordinary track only after summing these possibilities and letting decoherence shave away the self-cancellations. If you try to watch too often, you slow the act itself. The quantum Zeno effect, where frequent checking keeps a system from changing. It's a reminder that time passing for a quantum object is bound to the opportunities it has to evolve and to the gentle restraint of your gaze. Even causality, the sturdy ladder we climb in daily life, can wobble at the edges. In certain laboratory setups, the order of events becomes indefinite. One operation happens before another and after it in superposition until a final readout forces a choice. There is no single first baked in. Order is context, assembled when interactions complete. This doesn't throw the world into chaos. It shows that the hierarchy of then and later can itself be a quantum variable at very small scales. When processes settle and histories decohere, the familiar arrow snaps back into place. The arrow still leans on asymmetry. Entropy rises because ordinary conditions make rising likely. But probability is a shy sculptor. It works through counts and constraints. There are simply many more ways for the air in a room to be spread out than huddled into a corner. Leave the room alone, and the spread wins by arithmetic. The same counting yields a quiet principle of typicality. Most accessible states look scrambled. That typicality is what you feel as a push from yesterday's tidy to today's mixed. You don't sense the counting, you sense the nudge. There's also a thread of complexity winding through all this. In some corners of theory, the time it takes for a quantum state to wander from simple to intricate, the growth of computational complexity behaves like an arrow of its own. Entanglement spreads, and with it, the difficulty of reversing what has happened. This is not a happy metaphor laid on top of physics. It is a calculation that, in certain models, marches side by side with the growth of space-time volume behind horizons or the interior of wormholes. The message is the same. As relations tangle, going back requires knowledge and control you do not have. Pull close again to the simple question: how does a clock work, really? It isolates a regular change, fences it off from noise, and couples it to a counter. In the best clocks we've built, the regular change is a particular jump in an atom's energy, probed by light, tuned to just the right frequency. That jump isn't time. It is an event we can repeat with such stability that counting it becomes a kind of language. The clock doesn't feel time. It makes a public record of differences. You borrow that record to coordinate with others and to plot your own story. If the record is the reality, then time belongs as much to memory as to motion. An event without a trace is functionally invisible. The world could have slipped through 100 subtle rearrangements in the last second. If none left a mark you can read, the second will be blank to you. This is why an arrow built from entropy also builds from records. As entropy rises, heat and photons carry away information. The present contains many copies of clues about the near past, but few about the near future. You can check the soot and know there was fire. You cannot check the clean log and know for sure it will burn. A nice example lives in the sky. The afterglow of the early universe, thin radio light stretched into microwaves, bathes everything evenly. Embedded in that glow are tiny temperature ripples, fossilized when light and matter fell out of lockstep. Those ripples are records. They tell you that, long ago, conditions were smoother than today, but not perfectly smooth. Gravity read those faint differences and amplified them into galaxies. The afterglow is a photograph you did not take, delivered free to every horizon. Relational time also reframes now. We speak as though there is a single moment sanding across the cosmos, like a carpenter's plane, smoothing rough boards in one sweep. In relativity, there is no universal plane. Different observers slice space-time into nows differently, depending on their motion and gravity's pull. Your now and a distant galaxy's now need not match. What we call the present is a local neighborhood, an agreement among clocks that share a slope. The wider the network of comparisons, the bigger your usable now. The thinner the network, the more private it becomes. If time is correlation, then asking whether the universe has time when taken as a whole is like asking whether the dictionary has a story. All the words are present, but order lives in how you read them. Histories are readings that survive decoherence, the traceable paths that can be retold and checked. Without such stable readings, nothing is lost in the ultimate sense, but nothing is usable either. Usable time is the subset of change that can be organized into records and shared. There's another quiet ingredient: energy-time uncertainty. You can pin down a system's energy very precisely, but only if you let it sit long enough. Try to measure it quickly, and the energy becomes fuzzy. This isn't the same as the uncertainty between position and momentum. It is a statement about the trade between how crisp a frequency is and how long you listen. The sharper the note, the longer the echo you must allow. Clocks live on this trade. To be stable, they must protect the frequency and give it time to sing. Sometimes we flip the question around and ask whether the future can influence the past. In ordinary life, the answer is no, because records and entropy fix the direction of credible stories. In specialized quantum experiments, correlations can be arranged so that choices made later seem to decide how earlier paths interfered. The trick never lets you send a message to yesterday, and it never violates the overall consistency of all observers, but it does warn you that cause, then effect is a summary that may hide a more delicate weave. In the delicate weave, what matters are complete patterns that respect the rules, not individual arrows you can rearrange at will. Down on the human scale, the brain makes its own kind of relational time. It stitches perception in overlapping windows, tens to hundreds of milliseconds long, aligning sights with sounds and touch so that experience feels unified. That stitching introduces small delays. The present you feel is a best guess, a smoothed verdict that integrates slightly stale evidence. The guess is good enough to catch a ball and carry a tune, and it is flexible enough to warp under laughter or fear. Even here, time is a model built from correlations. Even here, the flow is a story your nervous system tells so you can act. None of this requires us to take sides in a final way. We can hold two reliable pictures at once: the equations that are happy to exist without a preferred direction, and the lived world in which direction is undeniable. The bridge between them is not a single law, but a stack of ideas: entanglement making relations, decoherence making records, initial low entropy providing an arrow, and observers embedded, limited building narratives from the traces they can reach. Between these layers, time is not denied, it is explained. Pull again on the deepest thread. If space and time are twins that emerge from a common parent, call it relation, information, or something plainer than the parent is where the real question lives. What must be true of a world for differences to exist at all? For some patterns to stabilize while others evaporate? For records to persist long enough to be read? The answer is maybe mathematical, not mythic constraints on what consistent structures are allowed. In such a picture, beginnings are not ignitions, but permissions. A universe appears because its rules permit it to be arranged in ways that can last. Under that light, the flow we feel remains as it always was, intimate and practical. You cannot hold it, but you can keep it. You cannot speed it, but you can fill it. You can trust that where there are relations sturdy enough to compare heartbeats, keeping pace with steps, words keeping pace with breath, time will make itself known, and where relations thin, it will grow quiet. Not absent, only beyond reach. So the small conclusion, for now, is humble. Time may be the shape taken by change when changes can be compared. The universe may not carry a master clock, but it carries structures that let clocks exist. Space and time could be co-emergent projects of something deeper: networks, correlations, constraints. And the arrow we feel is the way typical states settle from rare beginnings into common futures, leaving records behind like footprints you can follow. At smaller scales, where order itself can be superposed and event order can be indefinite, the story remains consistent because complete patterns, histories that can be recorded, are what survive. At larger scales, those histories braid into the rivers we call eras and lives. The mathematics does not demand flow, but the world grants it freely whenever differences can gather, whenever memory can last, whenever observers can compare notes. That is enough for us to live by, and enough to keep wondering what lies beneath the stage that lets any show go on at all. Time, then, becomes local, an inner arrangement rather than a universal commodity the cosmos keeps in its pocket. It appears when enough relationships are at play to make differences noticeable. The smallest workable versions of these relationships are often called quantum clocks. No gears, no springs, just systems that evolve in ways you can count. An atom cycling between energy levels, a two-state particle swapping its orientation back and forth. Use one part as a reference and watch the rest shift against it. The sequence you read becomes the time for that little world. But a clock like this only lives if the changes it tracks are distinguishable. The structure must be crisp enough to support comparison, and down where everything is smallest, it isn't always crisp. Quantum fluctuations jitter the very quantities you want to rely on. Energy levels blur. Even the geometry you would place them in can flicker. Near the Planck scale, lengths around 10, -35 meters. Uncertainty doesn't just hide the positions of particles, it fuzzes the shape of space-time itself. In some approaches, space-time isn't smooth at all, but a network, a web of connections that can rearrange. In that picture, time isn't a smooth line. It's the bookkeeping we use to order the network's updates. Hidden clocks live inside those updates, not as ticks you can hear, but as the quiet probabilities that one configuration will lead to another. You don't look at them directly. You infer them from the pattern they leave, like sensing the tempo of a song whose drummer has gone silent. Carry this to an extreme, and you could imagine defining time from within the full state of the universe, the amplitudes of every field, the correlations among them, without referencing an external now. In that sense, time is information, a measure of difference between successive, distinguishable states. When little changes or when systems are too simple, there isn't enough difference to define a direction. But as complexity rises, entanglement spreads, energy disperses, patterns sharpen, internal clocks appear. They don't synchronize by decree, and they don't always point perfectly the same way. Yet together, they frame a lived order that may echo the earliest era, before there were stars or atoms only, fields and tiny quantum systems, uncertain and scattered. As structure accumulated, those systems built more stable references, and out of that stability, larger forms of time took shape. This isn't hand-waving. The cleanest clocks we have are quantum through and through. An atomic clock defines a second by a specific energy jump in cesium or ytterbium. The tick is a transition. That our best definition of time depends on quantum behavior hints at something deep. Time isn't painted over the universe, it's drawn out of it. Change the rules a little, the constants, the couplings in these transitions might lose their regularity. In such a world, clocks could fail, not because metal breaks, but because the fabric provides no reliable differences to count. A universe might still exist as a single, unwavering solution, no events, no unfolding, a silent wave function. Ours is not that kind. It teems with motions large and small, and across them all, time appears as pattern rather than substance. Patterns can fade if time depends on change. What happens when change runs low, not rearranged, not hidden, simply absent? Matter is the easiest anchor we know. It supplies oscillations, decays, collisions, things to compare against things. Remove matter and many familiar clocks vanish, but the idea of time doesn't end automatically. General relativity allows vacuum solutions, no matter or radiation where geometry itself evolves. Curvature can stretch or settle under the rules, even without objects moving through space. In that sense, time exists, mathematically, a parameter that marches as the geometry solves its own equations, yet this time is thin, with no events to attach to. The evolution feels like running a simulation. On an empty grid, the cells update, but nothing takes the changes as experience. The scaffold remains. The drama is missing. Quantum theory complicates the picture further. Even a vacuum isn't absolutely empty. Fields fluctuate, particles pop in and out as brief possibilities, whether you treat those flickers as real or virtual. Perfect emptiness looks less like physics and more like an ideal we can approach, but never inhabit. Still, we can think about the limit as matter thins out. Black hole evaporation sketches a path. As a black hole radiates away its mass, the surrounding curvature smooths. Time near the horizon dilates. Outside it races along, but neither stops. If you follow the trend all the way to the future some models prefer, you reach a heat death, maximum entropy, no gradients left to exploit, no free energy for organized processes. The equations still include a time parameter. Solutions still extend, but with no structure to evolve. How long loses bite? Clocks that survive would tick without purpose. Like metronomes in an empty hall. Nothing would answer them. So does time still mean anything there? It depends on what you ask of it. If time is the parameter in the math, it survives. If time is a measured, felt difference records you can compare, then it withers when contrast does. You can test this with a thought experiment. Let a gravitational wave, a wrinkle of geometry, pass through a completely empty region. The wave has structure. It stretches and squeezes space. Put a detector there, masses and lasers, and you'll mark the rhythm in a record. Remove the detector, and the wave is just a solution the geometry realizes. It passes in equations, but no trace remains to compare. The reality of time becomes detached, not absent but ungrounded. The early universe shows the other flank of the same idea. There were spans when stable particles had not yet condensed from the energy-rich fields. Time could be parameterized by how those fields changed, but only once matter crystallized from energy could anyone, anywhere, have built a clock. That symmetry between the far past and far future is telling. When structure is scarce because the world is too hot and dense or too cold and diluted, time becomes blurry, not gone, but harder to use. What sharpens it is a supply of differences that can persist long enough to be recorded. This loops back to the only perspective we can never step outside of: experience. A person is matter arranged to make and keep records, cells with rhythms, neurons with pulses, attention with a beat. Remove those inner clocks, and time retreats to a theory, correct in equations, and silent in the room. That's not a demotion, it's a boundary, a reminder that for creatures like us, time is always practical as well as principled. We borrow the universe's stable differences to build watches and to bind a life into order. All of this sets up a deeper turn. It's easy to assume time sits in every honest equation, that anything real must evolve. But descend to the most sweeping descriptions, and something unsettling happens. Time drops out. Not in a theatrical vanishing act just omitted because it isn't required. Some of the frameworks that try to reconcile quantum theory with gravity describe the whole universe at once as a single wave function. There is no external clock to plug in because there's nowhere to be outside. The Wheeler-DeWitt equation is the emblem of this view. It writes the entire cosmos as a timeless object, every possible configuration present together, weighted by a rule. Nothing moves because motion would need a before and after, and those labels aren't available. You can picture this as a landscape of configurations. Each point is a complete arrangement of geometry and fields. The wave function tells you which regions are heavy with amplitude. There's no road drawn across that land, no sequence, no current. And yet, within certain regions, familiar behavior peeks through. Variables can play the role of clocks for each other. Choose 1 degree of freedom as a reference the clock, and read how others change when the clock takes on successive values. That reading is internal time. It doesn't come from outside, It's a pattern that arises inside the timeless whole. From that vantage, the universe moves, because you're measuring it with one of its own parts. Relational time makes peace with both pictures at once. The grand description can be frozen and complete. The local experience can be fluid and directional. Entanglement provides the relations. Decoherence pins down records. Low entropy beginnings grant an arrow. Observers carve a story by comparing traces. Nothing in this list requires a master metronome. Everything in this list explains why, for us, the present keeps arriving on schedule. There is an edge case that keeps theorists honest: the quantum Zeno effect. Check a system too often, and you prevent it from changing. Evolution slows as measurement frequency rises. It's a hint that time passing is not simply a backdrop, but an opportunity change needs room to occur, and observation takes up some of that room. Viewed through this lens, time is less a stream and more a permission slip for differences to accumulate. Where permission is plentiful, motion looks smooth. Where permission is scarce, motion stalls. Even causality can be subtler than our slogans. Experiments with indefinite causal order show that at tiny scales, the which came first of two operations can be in superposition. Only when you wrap the process up and look at the outcome does a definite ordering crystallize. You cannot message the past this way. Consistency stays intact. But you can learn that the tidy ladder of causes is itself an emergent structure, built when processes finish and records harden. Bring the discussion back to a wristwatch for a breath. The watch isolates a stable change and oscillation and couples it to a counter that won't miss a beat. The stability comes from energy-time trade-offs. The sharper the frequency, the longer the system must be allowed to sing without disturbance. Every precise clock is a small sanctuary where a chosen change can unfold, protected from noise, so the rest of us can borrow its regularity. That borrowing is how time becomes shared. The universe provides many local clocks. Communication and calibration stitch them together. Your now is not the entire cosmos. Now, relativity forbids that, but you can widen your present by syncing with more neighbors, comparing more traces, building networks of agreement. The larger the network, the more robust the public time becomes. In isolation, time thins toward the private. In community, it thickens into infrastructure. Turn once more to matter's role. It isn't that matter grants time existence, but that matter grants time expression. Matter lets differences persist. Rocks hold layers, trees keep rings. Light from a burst of stars keeps traveling, carrying a dated signature that can be read billions of years later. Records stack. From stacked records, arrows are drawn. Remove the record keepers, and the arrows fade from view. If a single sentence has to carry this chapter, let it be gentle and plain. Time is what change looks like when there is enough structure for change to be compared. Quantum clocks supply the microstructure. Geometry supplies the stage. Entropy supplies the leaning. Observers supply the reading. In the thin places, perfect symmetry. Featureless vacua, heat death. The structure dries up and comparison fails. In the thick places, living tissue, spinning planets. Bright skies, differences abound, and time feels rich, steady, almost tangible. That richness isn't a trick. It's an achievement the universe keeps earning wherever patterns can last. And because it is earned, it can also be lost. If the last lights go out and the last gradients relax, time won't stop in the equations, but it will grow quiet in every way that matters to anyone inside. Until then, there are still clocks to borrow and stories to keep seconds counted by atoms. days counted by shadows, years counted by the way memories braid into who you are. Each comparison, a small proof that difference remains, and with it, the kind of time a life can feel. What you feel as motion is relative, a story stitched from correlations, not a march led by a drum outside the world, but a structure you meet one slice at a time. In that sense, time behaves like perspective. It isn't in the total equation, because the total equation doesn't pick a vantage point. It lays out the whole tapestry at once. Only when a piece is singled out, only when a view narrows to one thread among many, does time begin to carry meaning. It isn't built into the laws so much as it is built into how outcomes are read by creatures living inside them. You can see this already in the everyday quantum rulebook. The Schrödinger equation speaks fluently about evolution, but the time it uses is something we feed in from the outside. It is a label, not an observable, the system produces for itself. The wave function doesn't know hours are passing. We do. In relativity, the looseness grows. Different observers ride different tracks of time, depending on how they move and how gravity leans on them. There is no universal now, no master clock that everyone can agree on without first agreeing on a frame. The geometry decides the bookkeeping. Pull far enough back, write equations that aim to cover everything, and time begins to slip from your hands, not because it's false, but because before and after don't apply to a description that includes all possibilities at once. That's one honest reason to suspect time may not be fundamental. It's not that we can't speak it, it's that we can finish coherent sentences without it. Then, the question of time's appearance becomes a question of structure. Which arrangements of matter and fields can host something clock-like? Which subsystems can play reference and be read against their neighbors? In that view, you're not watching time pass. You're watching yourself move through distinguishable states, tracing a thread through a timeless library. The direction you give that thread, the arrow rests on memory, not on the law. You remember the past, not the future, and the asymmetry in your remembering leans a direction onto the sequence. The arrow, like the path, is not a term in the equation. It is a feature of the way the equation is read from the inside. So when equations forget time, they are not broken. They are simply complete at a level where sequence is nobody's privilege. That completeness, however, doesn't settle your experience. You live inside boundary conditions, and those boundaries carve a slope. The idea of entropy ways to arrange the parts turns that slope into a quiet force. There are many more ways for air to spread through a room than to huddle in a corner. Leave it alone, and spreading wins by arithmetic. That arithmetic is what gives you an arrow, not because the laws push forward, but because the universe started in an exquisitely low entropy state. From that rare beginning, typical outcomes trend toward more sprawling possibilities. You don't see smoke reassemble, not because it's forbidden, but because it's buried under a mountain of alternatives. This makes the arrow a reflection of initial conditions. Had the world begun already scrambled to the hilt, nothing would have been left to unfold. No gradients, no memory, no clocks that mean anything. Change could still occur in principle, but with no contrast to anchor it. Now versus then would be empty. That is why entropy is more than a technical word. It explains why you can recall yesterday and not tomorrow, why a cup shatters and does not unshatter, why the sun warms your skin in the morning and not in reverse at dusk. Your own nervous system is part of the proof. It spends energy to make temporary pockets of order, snapshots, traces, associations. The feeling of a present sliding into a past is how that order gets written. The arrow you carry is resilient, yet tender. Sleep can bend it, shock can warp it, illness can smear it at the edges. The world's arrow doesn't fall apart, but your personal read of it can. That gap between equation and feel is another sign that the flow is not the law itself, but a translation. Some thinkers go further and suggest experience requires an arrow that, to be conscious, is to stand in a cascade of records, using what has just been written to shape what comes next. If so, then observers like us can only bloom in eddies where entropy points away. There is an unsettling thought experiment tucked in this. Imagine a region in perfect equilibrium, no gradients to tap, every part at the same temperature. The equations still list a time parameter, but nothing happens. The film is a single frame. In such a place, the arrow doesn't reverse, it evaporates. You can imagine a rare fluctuation, carving a tiny pocket of low entropy in that calm, just enough to let a brief arrow form, a spark of order that grows for a while and then is reabsorbed as the pocket dissolves back into sameness. Live inside the pocket and you would read a normal history. Step outside, if there were an outside to stand on, and you'd call it a blip in a sea of stillness. Some cosmologies stretch that idea to the scale of everything, a vast context without an arrow, in which our entire universe is one stunningly rare pocket where low entropy appeared and a long, rich story unfolded. If that's even partly right, the arrow is local to the pocket and not a rule the grand total must obey. The picture that emerges is not scornful of your senses. It is gentle about their origin. The direction of change is a perspective grown inside systems that can keep records. From the vantage of the deepest equations, all allowed states sit together in relationship. Nothing is singled out as earlier. We shine a narrow beam across that landscape, limited by attention, embedded in a body, and declare a path. The painting hangs whole. We walk with a flashlight and call the lit patches a timeline. When you ask what happens if that light fails, if time stops, you bump into two ideas that must be kept apart. Time as a parameter in equations, and time as the felt difference made by change. A parameter can continue in the background even when differences run out. A sealed gas will mix and smooth, and then do nothing at all beyond tiny fluctuations. From the inside, with no new patterns and no new records, later is just a label. In cosmology, heat death names a similar horizon. After unimaginable expansion, with stars gone and black holes evaporated, nothing useful remains to push structure around. The math still numbers the slices. The slices contain no new story. Geometry can mimic an ending even when it isn't one. Near a black hole's edge, time for you proceeds normally. Far away, your clock appears to drag and freeze as light from you climbs out of the gravitational well. At the horizon, the outside picture would label you forever arriving. For you, there is no halt. Stopping and going are about perspective, about which slice you live on, and how fiercely curvature bends it. On the grandest stage of all, time may not even be the right kind of question. Write the universe as a single wave function, and the vocabulary of next has no purchase. Ask when time ends, and you are searching for a break in a sentence that doesn't include verbs. From where we actually live, however, endings matter precisely because they are about structure. If gradients vanish, if interactions thin, if memory cannot be written, then experience stops not as an explosion, but as a fade. This also has a human echo. under anesthesia, or in certain deep phases of sleep. The brain simply doesn't make records. You surface into morning, and there is a hole where the night should be. Time in the equations marched on. Time as a difference you could keep did not. All of this brings the story back to a quiet center. Time is conditional. It depends on separations to compare, on asymmetries to lean on the presence of subsystems that can play clock and system for each other. Remove those conditions, and time dissolves, not in catastrophe, but in irrelevance. The labels remain, the pages are blank. Even so, the world you inhabit is full of conditions that favor time. Entropy's slope nudges structure to grow and decay. Relativity stitches space and time into a geometry you can navigate with calendars and distances. Quantum mechanics offers transitions so regular that we can define a second by listening to an atom sing. Networks of observers synchronize their local rhythms into public time. The hum of GPS corrections, the pulse of electrical grids, the calendar of seasons and tides. These are not decorations layered on top of physics. They are what physics looks like when it gets the chance to make records that last. There is a smaller, subtler source of confidence too. In microscopic experiments, order itself can be put into superposition. The question, which came first, can be left undecided until the process finishes and a measurement pins it down. At that tiny scale, order is not a permanent ladder, but a set of options that congeal late. Yet when processes are allowed to complete and when environments are allowed to gather the debris of interactions, definite histories crystallize. Decoherence, that gentle leaking of phase information into many degrees of freedom, turns ambiguous sketches into firm lines. The arrow reappears not as a decree, but as a result of records being made and kept. If the direction is a result, it can be fragile at the edges and robust in the middle. In the heart of galaxies and in the habits of cities, there is so much structure, so many interlocking clocks, that the flow feels undeniable. In lonely stretches of intergalactic dark, the arrow thins, almost theoretical. This gradient is not a failure. It is a map of where difference survives. You can hold a simple sentence to keep all of this close. Time is what change looks like when there are enough stable comparisons to read it. Entropy provides the tilt that makes one direction typical. Geometry provides the canvas on which intervals can be drawn. Quantum rules provide the discrete steps that can be counted. Observers provide the act of reading, stitching records into narratives. None of these alone is time. Together they let time appear, soft as breath and steady as daybreak. What follows from that sentence is as tender as it is firm. If the conditions thin, if structure runs out, if gradients flatten, if the last keepers of records go quiet, time remains in the equations, but drains from experience. If the conditions thicken, if patterns proliferate, if memory is cheap and signals are plentiful, time grows lush. You are living in a thick place. Clocks on wrists and in atoms, rhythms in hearts and in planets, memories piled into years. None of this proves that time is fundamental. All of it shows how completely, how beautifully, the universe allows time to be felt. So what happens when time stops? If you mean physically, when there are no more changes, then the system becomes static, uniform, undisturbed. If you mean experientially, when memory, contrast, and structure are gone, then there's nothing to perceive, nothing to report, not even a sense of waiting. From the inside, that might not feel like anything at all. And that opens a final possibility. The end of time isn't an edge, it's a kind of quiet, where nothing new occurs, no distinction, no measure, a place beyond the arrow, beyond the clock. The universe doesn't stop because that place is reached. It simply becomes silent. Whether that silence lasts a second, a trillion years, or an unbounded duration, no one would know. In that silence, the story of time, as we live it, concludes. Yet endings invite more questions. If time can fade, the universe can too. If the universe stops, what becomes of time? Does it leave with the lights, or linger as a bare coordinate? It depends on the ending you imagine. In one picture, expansion goes on forever. Galaxies drift apart, stars exhaust their fuel, black holes evaporate in a final whisper of radiation. Matter decays. What remains is thin and cold, a diffuse mist of long wavelength quanta strung across an ever-widening space. This is heat death. Nothing dramatic, just fading. No gradients to tap, no architecture to maintain, no useful information to shape events. Time, in this endgame, persists in the equations. The metric keeps stretching. But for all practical purposes, nothing happens. No events, no observers, no clocks. Time becomes detached from experience, present in the math, absent from life. Another path is the Big Rip. If cosmic acceleration strengthens without bound, the stretching of space eventually unbinds galaxies, then solar systems, then planets, then molecules, then atoms. Structure fails at every scale. Past some horizon, space-time itself ceases to behave predictably. Equations that guided us lose their footing. If time remains, it may be a word without a world duration, with no dynamics to mark it. Or the universe could reverse, slow, halt, and fold back on itself in a big crunch. Temperature rises, density climbs, structures melt into uniformity as everything converges. Time doesn't vanish there. Sequences continue, but toward concentration rather than dispersion. The singular finale is unknown, an end of space-time, or a bridge to a new expansion. Some cyclic models replace the singularity with a bounce, the end of one era seeding the next. In those images, time does not die, it reboots. But a reboot isn't a continuation. It's a fresh ledger without the old entries. There's also vacuum decay, the unsettling possibility that our cosmos is perched in a false vacuum, a metastable energy state. If tunneling to a lower state occurs, a bubble forms and races outward at light speed, rewriting the rules as it goes. No warning, no defense. Inside, time might still be definable, but not our time. The constants, the fields, the very logic that made clocks possible could be altered beyond recognition. These endings differ in speed and character, but share a theme. Time, in theory, doesn't need us. It doesn't halt because no one is left to mark it. Yet a deeper question lurks. In a universe without contrast, no new patterns, no records, what exactly is time doing? If every slice looks the same, later becomes a label with nothing to label. Imagine writing dates on blank pages. The numbers rise, the pages do not change. That is as close to after time as physics allows. Not a wall, but a state beyond use. Some go further and suggest that when structure truly ends, the concept of time ends too, not merely practically, but fundamentally. If the final state is not even a state, if rules dissolve with content, then time may fail as part of the description, not erased, just inapplicable, like asking for the color of a silence. Whether frame or function, time brings us back to a human edge. If the universe quiets and no external clock survives, Could time persist only where the last comparison remains inside a mind? Memory shapes your sense of time, not by storing the past like files in a cabinet, but by weaving order: before, now, later. Without memory, there's no sequence, only unlinked frames. Experience collapses into moments that can't refer to one another. Memory doesn't merely tag events, it builds the bridge between them. Neurologically, that bridge is change. New experiences alter patterns of activity. Connections strengthen or weaken. Traces form. Recalling recruits and rewrites those traces, and with each act, the past is rebuilt enough to hold shape. Your sense of a flow is not manufactured by clocks. It arises as the present is continually compared with a short trail of receding presence. That comparison creates motion in awareness, even while the world simply continues to be. We can see the hinge in extreme conditions: trauma, anesthesia, certain phases of sleep when recording stalls. The world moves. Your internal ledger does not. You surface with a gap where the span should be. Time continued in the world. Your version didn't. Memory also explains the asymmetry you feel. You remember the past, not the future. Even though some formulations treat both as equally there, memory works only after an event, leaving physical traces that can be read. Information flows from change to record to use. Even recalling an event alters the trace you rely on. Your timeline is a living document. In that way, time and experience is active construction, not passive exposure. You are not watching a river. You are binding a story. Now, press this to the imagined endings. In heat death, there are no signals left to record, no gradients, no novelty. There is nothing for a brain to write down, even in principle. In a big rip, the instruments and the hands that would read them are torn apart. In a crunch, records are erased by pressure and heat. In vacuum decay, the archive is replaced wholesale. In each time may persist in mathematics, while the ability to host memory vanishes. If time requires difference to be felt, then where difference cannot last, time cannot be kept. This puts your role in a clear light. You are a keeper of time, not by counting, but by holding difference. Cells fire, rhythms couple, patterns stabilize long enough to be compared. Culture amplifies this. Calendars and anniversaries, rituals and seasons, photographs and stories, a web of records that reaches across generations. None of these make time exist. They let time endure as something shareable. Without records, the arrow loses traction. So where does that leave the core question? Does time exist without the universe? We have learned to answer with care. If exist means a parameter and a total description, perhaps yes. A symbol can survive abstractly wherever a theory needs it. But if exist means a structure that does work, organizing change, anchoring memory, providing direction, then time requires a world rich enough for differences to arise and persist. It requires clocks in the broadest sense, processes that repeat, patterns that decay, systems that can be compared. In that sense, time and universe travel together. Without a stage for change, time has nothing to do. Seen this way, beginnings and endings take their gentlest form. The beginning of time wasn't a drum roll. It was the first allowed difference, when symmetry gave way just enough for ordering to become possible. The end of time is not a cliff. It is the thinning of distinction until ordering can no longer be sustained. Between those two quiets, time is the shape that change takes, when change can be compared. And you warm in the night, listening, are part of how that shape holds. Your attention stitches moments into a line. Your memory keeps the line from slipping. Your expectations lean the line forward. You are not outside time, but you are not merely inside it either. You co-author the version that matters to you, turning impersonal dynamics into a life that can be told. When fear rushes in, your inner seconds stretch to make room. When joy rises, they fold close. The cosmos doesn't accelerate and decelerate because of your mood. Your model of time does, because it is built to keep you safe and present. From physics, we borrowed 5 gentle truths and set them beside this personal one. First, the deep equations rarely choose a direction. Arrows come from conditions. Second, space and time are woven. To measure one, you inevitably use the other. Third, at the smallest scales, order can be indefinite. Causality can blur until records settle it. Fourth, clocks are promises protected from noise. Precision is a sanctuary, not a given. Fifth, complexity and entropy grow together. As relations tangle, going back requires knowledge and control no real world can supply. When you put it all together, a quiet conclusion emerges. If there were truly no universe, no differences anywhere, no relations to be made, time would have nothing to do. If there is a universe but no structure, time remains in name, not in use. If there is structure but no observers, time can order events without being experienced. If there are observers but no records, time cannot be kept. And if there are observers with records, hearts beating, atoms ticking, thoughts returning, then time becomes what we live within, not a substance, but a relation made durable. The final picture is not bleak, it is tender. Time is not a tyrant outside you, nor a trick inside you. It is a relation that appears wherever difference is held long enough to compare. The universe gives you the raw materials, space-time's geometry, quantum transitions, the one-way nudge of entropy. You give it memory and attention. Between those gifts, a life stretches, and the seconds become bearable and warm. So if you ever wonder where time goes when it seems to vanish on a sleepless night, in a lost afternoon, at the bedside of someone you love, remember that time hasn't fled the room. It is waiting in the difference you can still hold. The rhythm of a breath, the softness of a word, the way a thought returns. Hold one difference kindly, and another will come to join it. That is how time reappears. We end here, not with certainty, but with ease. Time may or may not exist without a universe. It may or may not outlast any world we know. But as long as there is something to compare and someone to remember, there is enough. Enough to live, to rest, to let the arrow point gently forward. Thank you for sharing this stretch. May your own time drift slow and kind, and may sleep find you in its unhurried way, carrying you across the quiet night and into a morning that feels simply right.